sum all those. Anyone know the first step? Aiden? Well, we would put them together is true, okay? But if we were graphically doing it, we would put them together at the right angles and all that, okay? So these angles are, it's not drawn to scale. So graphically, yes, we would put them together head to tail. But in this case, we're doing mathematically. Maya? We would use trig to find what? Okay, so step one. Okay, step one. Use trig to get components of each vector. Okay? Now, the first vector, A, looks like that. Now, I'm not so concerned about length and stuff, right? Because we're doing this mathematically here. You see the difference? But I can see here from A that I have an AX and I have an AY and I need to find both of those. Oh, and the angle of 30 to 35 degrees. Okay. So, anybody remember the formula for AX? Well, it's on your reference sheet. Right. On your reference sheet, it says Rx equals R cosine theta. So in this case, it would be AX equals A cosine theta. AX is 20 meters cosine of 35 degrees. Now, everybody should have their calculator out and calculate what that is. Because if you need to get this, if you're making mistakes with the calculator, we need to make them now so we can figure that out. So AX is 16, the train's coming, or there's an earthquake. Oh, just a train. 16.4 meters. AY, if you look on your reference sheets, it says, okay, so it would be what trig function? Sine, because sine is associated with opposite, right? Good. So A sine theta, 20 meters, sine 35 degrees. When I do that, I'll just 20 sine 35, 11.5 meters. Both of those are positive because in the positive x and positive y, right? All right, so we have that. Is there anyone who's plugging it into their calculator and not getting the right answer? No? Anyone? Bueller? Okay, so let's see the next one. B. Well, B was 25 meters at 90 degrees, but we can see the 90 degree one means what and what for our BX. BX and BY we can get right away. Because bx would be what? 0, wouldn't it? It's all in the y. So b, exactly. So that one's easy because it's all in the y direction, right? Then we come up to the next one, which is C, and C is 15 meters at 100 degrees. Like that. Now, it's okay to get the 80 here, like that, but you could also just put it in as 100. That would work too. Because when you put it in as 100, it's going to tell you your x is what? Cx would be what? Positive or negative? It's negative, isn't it? See which direction it is? So when you put it into your equation, Cx is 15 meters cosine of 100. Oops. You get minus 2.6 meters. Okay. But if you used 80, the angle to the x-axis, that would be fine too. You would see from that, though, that you would, from your sketch, that you would have to make x negative. And then cy should be positive. So when we do 15 meters sine of 100 degrees, we get 14.8, positive 14.8 meters. Now we've broken it down into the components of each vector. Okay? We had 3 vectors we're adding. We want to find the resultant of the 3 vectors. Now the next step is to add all x components, get our x by doing that, and add all y components and get our y. Okay, now all the x are in the same direction, so now they just add up this plus that plus or minus that. Okay, so our Rx would equal 16.4 meters plus 0 meters minus 2.6 meters. Gotcha. Because the first component for the first vector was in the x direction was 16.4. The component in the x direction for the second vector was 0, and the component in the x direction for the third vector c was minus 2.6. So that gives us 13.8 meters. In our y, our first one is 11.5 meters for vector A. For vector B, we have 25 meters. In vector C, we have 14.8 meters. Huh? Is that what it is? 51.3 meters. Yeah. Oh, it is a summation. You're right. Yeah. Yes. It's basically like that summation of Rx is you're summing all the X components. Yeah. So if you look, which brings us to the next point. Now, step 3. What's the next step? Huh? Well, what was it? What's that thing? What? T-sag, right. Pythagorean theorem. To get R. Now, when we put this little bar on it, that means the magnitude of R. Because we're not going to get the direction of R from Pythagorean. We're only going to get the magnitude. So the formula looks like this. You're going to find it, but it's just Pythagorean theorem. It's written on your card, but it just means all the sum of the sigma means sum. And that means sum of all the x components squared. That's like your a squared plus the sum of all the y components squared. That's like your b squared, and this is like your c over here, and it's square root. So I should have made it a different color, but anyways, equals, our Rx was 13.8 meters plus 51.3 meters for Ry, and square that. So 13.8 squared plus 51.3 squared is 2,822.13. Square root of that is 53.1 meters. So the magnitude, R, is 53.1 meters. It's mostly in the y direction, isn't it? Because look at what y value of Ry was 51.3, and it only went up a couple with the x. Well, no, the y component was 51.3, but it's the fact that this is 53.1 is showing us that most of it is in the y direction, right? How do we get direction? This is the new part. Mary, you want to tell me? Well, directions is going to come from, okay. Okay, we'll use trig to get theta, we'll just say. That's its direction, because that will tell us where we are. And I like to draw a picture for it, okay? So we summed up the Rx's. And when we summed up the Rx's, we got 13.8, right? When we summed up the Ry's, we got 51.3. I'm not drawing them to scale, but so our vector R, right? If we connect those from the tail to the one to the head of the other, there's our vector r. We know its magnitude. It was equal to 53.1 meters. We found that by doing Pythagorean, right? Because these are at 90 degrees to each other. Right? We did that. Now, to get theta, this theta here, can you see that yellow? A little bit? We're going to use the relationship of tangent because we have our y and our x. So if I look here, tangent of theta equals the opposite over the adjacent, right? Remember Maritza's Sortoa, right? We don't know what theta is, but we know in general O is our y, and that was our x. And so our opposite is our y, the adjacent is our x. Yes. You can't see it. Okay. I know, but I'm running out of colors here. How about this? Is that good? No, I'm just kidding. Actually, teal, I really like the color teal. But I don't know if that will show up very well either. All right, now we're good to go. Oh, now I got it in. Now it's in black, but whatever. Fine, who cares? Okay, so now this brings up the opposite of tangent. Like the opposite of subtraction is addition. The opposite of tangent is tan inverse. So if we tan inverse both sides, the tan inverse of tangent just gives us theta. That's why we did it. So we also need to do the tan inverse of our y over our x. So this is a good formula to remember, is that tan inverse of our y over our x will give us our angle that we're at, or at least give us the acute version of it, and then we could figure out what quadrant we are by whether x is positive or negative and y is positive or negative. So our ry was 51.3. And our x was 13.8. The meters cancel because there's meters on top and meters on the bottom, which is good. Let's get degrees out of it. Now what we're doing here is we're going to use the second tan inverse button, right? If I still had a video cassette player that worked, because I have VHS of sports figures, ESPN sports figures, they have a good soccer one, and they have sports people on, like Derek Jeter and stuff like that, but he's not a soccer player. But they have one of the women who won the World Cup back in, like, I don't know, 1990-something or something like that. And but it's on those old VHS. But you can watch it if you get up and watch ESPN or their subsidiary channels and watch it at like 2 a.m. in the morning or 3 a.m. You might find sports figures. Get your head in the game, right? Anyways, soccer players would probably like that one. So if you have a VHS and you want to borrow it or something, maybe you can. Anyways, what are we asking when we do? We're going to do second or shift tan inverse, and then we're going to put in 51.3 parentheses 51.3 divided by 13.8. It should be high on the y, small on the x, so an angle of like between 70 or 90 degrees. 74.9 degrees. We're asking, we're telling the calculator, okay, we're saying, here's this ratio of the opposite side over the adjacent. In a right triangle, what angle does that correspond to for the opposite over adjacent? So the calculator doesn't really care that it's 51.3 and this is 13.8. What it cares is the value of the ratio of it, that divided by that. And it will tell you what angle that corresponds to. So that gives us our direction. And so now we've solved it with both x, y, and the direction. Okay? That's pretty much topic 1. Yes. Why what? Did we do -1? We use the -1, okay, when you're getting the angle. If you remember that, you'll be good, okay? So use the negative when you're getting the angle. In the other case, we're saying what is the rate? When we use the regular one, we're saying what is the ratio for this angle? And it gives us the ratio. In this case, we're saying given this angle, or no, given this ratio, what is the angle? You see the difference? Okay. So inverse tan gives you the angle, right? How can we remember that? Inverse angle. -1, you can think of it as an I inverse. That might help. What else? Inverse angle. You can just remember Ian. You know that kid Ian? You always like to get inverse angles. IAN. Right. Right? Does that work? My mnemonic for the geologic time scale. Who's learned the geologic time scale? Well, when I learned it, my geology teacher said, you'll never remember that. So she gave me a bad grade on my mnemonic. But cool ocean sunsets dip mysteriously. People cry, people think. January colors perform endless orchestration, making poetry that people hear. Cool ocean sunsets dip mysteriously. People cry, people think. January colors perform endless orchestration, making poetry people hear. I do, right. She said I never would. So, huh? I know. That's all right. Let's see. If I made it up today, I would never remember it. That's the funny part. But back then, I had some sort of memory. Okay, so on Monday, you could turn in your packets by the end of the day for some extra points. However, you shouldn't rush through and feel like that's the due date, because the due date is actually Tuesday. And on Tuesday, you can bring your packets to class. It's on Tuesday, and we can work on them for a bit if you have a couple questions. Due by the end of the day. The earlier the better. But you do have everything you need to go, and we have been working on it as we go along. So in that sense, we're making progress having it done, yes. No, on the packet would be the best. But if you need to staple pages to it, that's okay. Yeah, just if you do it on separate sheets, make sure you have the answer, and then you just say "see attached," and then staple it to it. Okay? But I would rather have it on there, although I know it gets crunched. It gets crunched because, like I tried to get it down to 14 pages. Like this one's 19, so in the effort to not have it so big and take up so much paper. Okay? Let's look at some problems from it. So Let's look at this one. Oh, we did this yesterday, didn't we? All right, so we don't need to do that again. Let's just go back to it. Oh, yeah, well, okay. So if you go to, on your web, on here, and you go to topic 1, oh, you'll see that it says, maybe, it says corrections to packet. See that? And then on 14 of 14, triangle 4 and 5 should be 3 centimeters, 4 centimeters, and 5 centimeters for hypotenuse. And for circle 6 and 7, the radius should be 3 centimeters. Okay? Now, I noticed on the one that we're looking at now, here, the next problem, I'll show you something too. In 11, it says, use the results. What did yours say? Question what? 12. It should be 10. Okay? Above. And it says use your results to find the vector C, which is A plus B. See that? So in this case, we did A, we found A, we found our AX, and we found our AY, but when we're looking at the steps of adding vectors, what else do we need to do? We found AX, and we found AY, but we also need to find BX and BY first. See? So for that, we have 8 meters and we have BX and BY, okay? And this is the angle 150. Because we've done a lot of this, BX is just 8 meters cosine 150. BY is 8 meters sine 150. Okay? So 8 cosine 150 is minus 6.9 meters. And 8 sine 150 is 4 meters. So I'm finishing up question 10. On question 10, I'm sorry, we did A, but we never did the B. So some of you probably did it on your own. I just never wrote it down or something? What did I do? Oh, I made you do it at your seats. Yes, now I remember. Yes. Okay, so you should have that on there. Well, now I have it too. Now, what would be the next result for finding the magnitude of C? I have the components, AX, AY. This is 11 on the next page. That should say question 10, yeah. We have to do what? Yeah, we're going to, well, even before that, we're going to add up our X. Our X is 19.9 meters plus a minus 6.9 meters. So our Rx is, this is for, oh, this is actually for A, but I'm calling it R. I should have called it C. Sorry. Cx. But C is the sum of A and B, okay? That's why I put it as R. So Cx is equal to 13. Ooh, that's nice. And Cy, so this is A, Cy is 11.5 meters plus 4 meters, right? From up here, which gives us 15.5 meters, right? So that means we have a Cx equal to 13 meters and a Cy equal to 15.5 meters. We're going to find vector C, its magnitude now, and we're going to find its direction as well, theta. Maya? All right. If you have space, just put it in for this. Yeah, okay. Oh yeah, you could, it's A and B there too. Yeah. It's supposed to say 10. It's okay if you did it for 12. If you just follow along, see if you did it right. You have the answers, so the answers that you have below they won't make sense. But that's okay. Okay, my mistake. How do I find C? Pythagorean theorem to get the magnitude of C. And it's just the sum of the x vectors, which is 13 squared, the square root of the sum of the x vectors plus the sum of the y vectors. That equals square root 13 squared plus 15.5 squared. Whoops, gosh. $20.2 meters. And then I get theta with the tan inverse of y over x, cy over cx. Okay? We can see it should be 45 degrees if those were exactly equal, right? But y is slightly bigger than x, so it should be slightly more than 45 degrees. And what do we do, Mary, when we want to ask our calculator for an angle? Right, that's right. Tan inverse 15.5 divided by 13 is 50.0 degrees. Depends. I think I'll have to. There's a thing, some of you may have chemistry, there's a thing called significant figures that you've probably learned about. Sig figs, yeah. I used to teach that in the last couple of units of physics. You definitely learn it in chemistry. And there's certain rules about how many digits you should have in a number based on your measurements. So if you use whatever. I won't go off on that tangent. Anyways, it's going to ring, so we'll end it there. So let's. Did we